All right. Good morning, students. How are you all? I hope you are all good. All right. Good morning, students. Good morning to all. I hope you all good. And yesterday was sent to you all completed miscellaneous exercise of chapter number 5. And today we are going to discuss chapter number 6, applications of derivatives. So this we are going to discuss today. Just introduction and some, I think some examples are there. Those examples we are going to discuss today. So I think there are six examples are there. So we'll discuss that. Sahil Garima Singh, very good morning. And just check now right now whether the video and audio clarity is good or not good. So if everything is good, then we will start our class. Firstly, inform to me. And what about Vinod and Sahil and Vaishnav? So these names also I want to find in the comment section. If you are present, just say that good morning, sir, so that I get to know. Garma Singh firstly answer so that we will start. So anyhow, meanwhile, just we close our eyes and we will seek the presence of God. Good, sir. Okay, very good. So let us close our eyes and we'll do prayer. God kindly provide your knowledge and wisdom to solve our mathematics problems and our daily life problems. Thank you, God. All right. Now, today we are going to discuss applications of derivatives. So, for that purpose, we just need to go for the introduction. I go with the book itself. So, in this first, there is Whitehead. He was said that with the calculus as a key, this derivatives, differentiation, integration, and this all together will say as calculus. Okay, it's a branch of mathematics. In that calculus, derivatives, applications of derivatives, integration, then applications of integration. This all together will say as calculus. Okay, so he was written one thing that his name is Whitehead. With the calculus as a key, mathematics can be successfully applied to the explanation of the course of nature. See, to explain the nature, this calculus need to be applied, then we can understand the nature in a great manner. This was explained by Whitehead. Okay, so now let us go for the introduction in chapter number 5. What we have discussed. So we have learned to find derivative of composite functions, inverse functions, trigonometric functions, implicit functions, exponential functions, and logarithmic functions. These are all functions and derivatives how to find. We learned in the chapter number 5. And we will study in this class applications of derivatives in various fields or in various disciplines. So, such as engineering, science, social science, and many other fields. So, in all other fields, how we will apply these applications of derivatives means how we apply the derivatives to the fields. So then, not only this, not only engineering, science, social science, the other fields also we can apply these applications of derivatives. So we'll apply the derivatives, and especially in that hardware industry also nowadays we are using this to make the chips and all. Chips in the sense I don't think that eating chips. It was the computer chips. Okay. All right. So next we'll go for next one that in that we will learn now today's class. Actually, here we learn in this chapter to determine the rate of change of quantities. So any quantity with respect to another quantity, how that rate of change is going to be happen that we are going to discuss in this chapter. And second point we discuss in this chapter is how to find the equation of tangent and normal to a curve. If a curve is given, for that curve, any curve is given. For that curve, what is the tangent? What is the normal? So normal and tangent both we are going to discuss. Okay. So anyhow, that is about the second one we are going to discuss, and third one we are going to discuss. Find the turning points on the graph of a function, which in turn, with the help of locate points at which largest or smallest value of function occurs. In the sense, what they are saying is simply we can say that how to find the maximum and minimum of a curve. What is maximum, what is minimum. So that derivatives also, by using the derivatives, how to find what is maximum, what is minimum. So minima and maxima of local points we can by using the derivatives. In this chapter, these 3 points we are going to cover. Okay. So now the first point, it is rate of change of quantity. So now we are going to discuss rate of change of quantity. So our first topic is rate of change of quantity. Okay. So rate of change of quantity is nothing but, for example, speed is there. So speed is differentiated with respect to t is happening. That means d by dt of s. So differentiated with respect to t, the speed. Then whatever your answer you are going to get, that is the rate of change in speed with respect to t. T is nothing but here time. With respect to time, rate of change in the speed is whatever is there that we are going to find later. But what we want to discuss today is, so what is rate of change of quantity? So rate of change of quantity is nothing but this d by dt of s is nothing but here differentiation with respect to time to the speed. It indicates the change according to the time. If you go for some other also, not only time, in some places we will go for some other also. So let us see some examples, then you get to know. Anyhow, yes, with respect to, for example, area of circle. Area of circle, you know that pi r square. So this one we can do that with respect to r. So now we can do differentiation with respect to r. Then it is area of circle. We may say a d by dr of a is equal to pi is constant d by dr of r squared. So r square is 2r. So pi into 2r, that is 2 pi r. So here it is rate of change with respect to radius to the area of a circle is 2 pi r. Okay, so you just remember this. Okay, today I think Kusum also present today. Very good. Many days after you are present. Alright, so today what we discussed now? So we discussed here in this chapter number 5. It is chapter number 6. In the last chapter, what we discussed of derivatives of implicit functions, explicit functions, and trigonometric functions, composite functions, exponential functions, and logarithmic functions. So now what we are discussing here, those are functions, are the derivatives where you are going to apply. So we are going to apply in this chapter, we are going to apply on first one rate of change, and second one we are going to apply that how to find the tangent of a curve and how to find the norm of a curve. And thirdly, we are going to find what is maxima, what is minima. Okay, so these places, how we are going to apply that we are going to discuss. Now we just observe here it is what rate of change with respect to another quantity. What is actual rate of change? What is rate of change of quantity? So if any quantity is there here, any quantity that is with respect to another quantity is a differentiated, then that is called as rate of change of quantity. So one quantity is with respect to another quantity differentiated, then we can call that as rate of change of quantity. So meaning of that it is one quantity is varied, one quantity is varying depend on another quantity, then that is called as rate of change of quantity. Last time I was explaining to you this. So there is one, I say, think that from school to that Sumapur, whichever the distance is there, so you are covering by your bike thing. So when you are covering by bike, so it is some places you will go very fast, some distance you go slowly, some distance you go speed as medium speed. So that time here the speed is varying according to the time to time. So beginning it is going to be very slow, and middle it is going to be average speed, and then later a high speed. Then whenever the speed breakers come, it is low speed. So that indicates that, so according to that time, the speed is varying. So we can say that that is nothing but rate of change of quantity. Clear now? So if you are having any doubt, you can ask me now. Is anyone having any doubt in that? Till now, what I was saying in that, if you have any doubts, you can ask me. If you are not having doubts, you have to remember some formulas. Those all formulas I'll write on the board now. Just copy it down because in the notebook I may give or I may not give. So you just remember those all. Okay, till now you all understood everything. Very good. So now we just remember some formulas. Without remembering those formulas, it is not possible to solve our questions of exercise number 6.1. So if you want to solve exercise 6.1, you have to remember all these formulas. Remembering formulas. So you have to remember this one. The first one it is volume of a cone. V cone. V cone is nothing but volume of a cone. 1 upon 3 pi r square h. And second one it is volume of a cube. It's equal to x cube. And your third one it is volume of cuboid is equal to length into breadth into height. And then next fourth one it is volume of sphere 4 upon 3 r cube, and your fifth one is your volume of cylinder pi r square h. So remember these all formulas, these all very important. 7 circumference of a circle. Circumference of circle is equal to, it is 2 pi r. And next one, seventh one is area of circle. A circle is nothing but area of circle, that is pi r square. Next, total surface area. Surface area of cuboid. I hope this all you learned in your 9th and 10th classes, but once again we need to recall this now. 2LB plus BH plus LH, and your ninth question is, ninth formula is total surface area of cube. So that is nothing but 6x square. So now 10th one is total surface sphere. So total surface area of sphere. So firstly write down this all 4 pi r square. So firstly write down these all formulas and remember this all. Within tomorrow, however you want to learn, you can learn, but you have to remember all these formulas. So now these 10 problems, if you are finished, inform to me because total 13 formulas you have to remember. So up to 5th formula you are written. If you are written, just keep the thumb symbol so that let me know. Garba Singh, have you written these all 5 formulas? If you are written, just keep the thumb symbol so that let me know. Very good. So if you are written that, here I am going to write remaining 4 formulas. You have to remember these all. Without remembering these formulas, not possible to solve any single problem in that 6.1. And not only that, examples also. So now 11th one, total surface area of cylinder. Total surface area of cylinder is equal to 2 pi r into r plus h. And next, 12th one, total surface area of cone. Pi r l plus pi r square. And 13th one, curved surface area. Curved surface area RL. So these are 13 formulas you have to remember. When you remember all these 13 formulas, then you can solve whole chapter. So you just ask me now. So if you have finished this, ask me to solve these all problems. So let us solve it. Example number 1. So if you are finished, inform to me. I'll give 60 seconds time to complete this. After completion of that, we will solve our example number 1. Then you can understand clearly how to solve this. If you are finished, keep that thumb symbol so that I get to know that you are finished. Then I will start example number 1. So today we have to finish that example number 6. Till example number 6 we have to finish. Okay, that must be done, sir. Okay, if you are done, then I will rub. So, Kusum, you are also finished learning. So, writing part finished means inform to me. So, finished? Okay, very good. So, now if you are finished writing part, then we will go to examples. So, today we are going to discuss example 1 to 6. So, let me write question first. So example number 1, it is find the rate of find the rate of change find the rate of change of the area of area of a circle with respect to its radius r when r is equal to 5 centimeter. See, such a wonderful question it is. Just concentrate clearly now. So find the change of circle area or area of a circle with respect to what they said, radius. Radius or they said. So now what we'll do? First we'll write area of a circle formula. So let me write here solution. So area of circle, comma, A is equal to what is in our formula? Area of circle formula. Can you type on that? So that let me see. Type in that comment section. Firstly, area of circle is what? Now only given for you all formulas. Just check in that and inform to me. What is area of the circle? Not saying, see. They said first find the area of a circle with respect to radius r. We need to find that. First tell to me what is area of a circle. Anyone type on that comment section? Okay, very good. Pi r square. Very good, Garima Singh. So pi r square. Good. So now what we'll do here it is now differentiate with respect to r. With respect to r. Then d by dr of a is equal to pi is constant d by dr of r square. So what is your answer now? dA upon dr as it is. That means what is meaning of the rate of change of area of a circle with respect to radius. That is equal to pi d by dr of r square is nothing but 2r. So at last dA upon dr is equal to 2 pi r we got. But they said here when radius r is equal to 5 centimeter, what is rate of change of circle? You are understood now. Up to here we find general rate of change of area of a circle with respect to radius. But now at radius r is equal to 5 centimeter we want. Such kind of time what we do is d r a big line draw. So that indicates that at what is meaning of that differentiation of area with respect to r at r is equal to 5 centimeter. Like this big line you have to draw. When you are reading time, you need to read this as at. Okay, so that is equal to we'll write 2 pi wherever r is there substitute 5. So at last we get answer as here 5 2s are 10. 10 pi 10 pi we get answer as 10 pi. So 10 pi is what? So they were not mentioned whether it is centimeter or okay, it is centimeter they were mentioned, right? So that now we'll write area means centimeter square, but it is they say per second. So that centimeter square per second. Here now, any doubt up to here? So you are understanding what I was saying now. So first here they said find the rate of change of the area of a circle per second with respect to its radius when r is equal to 5 centimeter. First we are finding with respect to its radius. So area differentiate with respect to r we done. We got as dA upon dr is equal to 2 pi r. After getting that answer, when r is equal to 5, we need to find the change. So that at r is equal to 5 centimeter is equal to 2 into 5. Wherever r is there, substitute 5. 5 to the 10, 10 by. You know that area always in square. So that here centimeter square. Because here centimeter given centimeter square. Meter given means meter square. And they say per second. So that per second. Clear now? So I think everything understood. And what about Kusum? Kusum, you are also understood this? Or not understood? Fastly inform to me, Kusum. So if you are understood, we'll go for second example. Okay, you are understood. So let us go for now second problem, which was little big only, but you just concentrate what I was explaining on the board. So if you are understood that enough. So I think you all written this all whatever was written on the board. So that no need of the notes also. So now example number 2, the volume of cube is volume of cube V cube is increasing at the rate of 9 cubic centimeters. So volume of cube is given as 9 centimeter cube per second. The given volume of cube is increasing at the rate of centimeter per second. Second is nothing but it is with respect to time. So d by dt of volume of cube is equal to 9 centimeter cube per second given. And secondly, what they given here? How fast is surface area increasing when the length of an edge is 10 centimeter? Length of edge is nothing but side they given. Side is equal to the given as 10 centimeters. Side given, volume d by dt of v cube given as 9 centimeter per second. So we need to find here it is how fast the surface area is going to increase. That indicates that time we need to find how much fastly it is going to increase. So let us see now how it is possible to solve this problem, and so that we can understand how to solve these all problems easily. Without knowing, it is going to be very difficult for us. So let us write now what is given in the question, and according to that we will solve. So now first given is this. So write given dv cube upon means volume of a cube upon dt is equal to 9 centimeter cube per second. Now here it is d by dt of what is your volume of a cube formula? Volume of a cube formula was given to you right in the formulas. Can anyone write on that? Volume of a cube. Fastly write down. I want to know what is volume of a cube. Anyone write fastly? So what is volume of a cube formula? V cube formula. Side given, and anyone first tell to me what is V cube formula? Not Q by 8, Q by 1. Type fastly in the comment section. Fastly type in the comment section so that I get to know what is V cube formula, volume of a cube. Taking time so much. fastly. Still taking time. Volume of a cube, not cuboid. I was given already formulas. You all said, sir, we have written formulas. Tell to me what is volume of a cube. Taking so much time. Garima Singh, firstly right. Still, how much time you all will take? I'm waiting for your answer. Okay, I think it was maybe from the comments and all in my. All right, actually, my comments box was like everything was struck. Okay, no worries. Thank you. You have written that x cube. So that is equal to 9 centimeter per second. Will write or only 9 also you can write. So now here x cube formula d by dx of x cube means 3x square. So now first you apply d by dt of x cube is nothing but that formula only apply. So then you get as 3x square. Then inside whatever is there, that different is there, so that we have to apply. That means dx upon dt according to the chain rule we solve. So that is equal to 9. So I'm not writing now centimeter cube per second and all. So now at last find what is dx upon dt. So now we'll find here dx upon dt is equal to 9 upon 3x square. 3 3s are 9. Then at last we'll write here dx upon dt is equal to 3 upon x square. I need to find what I need to find. In the question they said, how fast is the surface area increasing? We need to find first surface area. Surface area of cube. Yes, cube is nothing but surface area of a cube is nothing but what do you have formula? Surface area of a cube with respect to time. Okay, first surface area of a cube, you know that 6x square. You know formula is total surface area of a cube is equal to 6x square. Let us apply now for that differentiation with respect to time. So ds cube upon dt is equal to 6 constant d by dt of x square. So now this will write 6 d by dt of x square is nothing but 2x. Then here d by dt. D by dt of what is inside x. So we are using chain rule. First we apply x to the power of n formula. X power n is nothing but n into x to the power of n minus 1. Or you just remember d by dx of x square is nothing but 2x. But here different terms are there. That's the reason dx upon dt written again. So now that is equal to 6 2s are 12 x dx upon dt means already you found one answer here. Just substitute this answer here. So what is that? 3 upon x square into 3 upon x square. This is ds upon dt. ds s is here s cube. So cube total surface area. X and square get cancelled. At last, what you are going to get your answer. So d by dt of s cube is equal to 12 into 3, 36 upon x. But here side x is how much? 10 centimeter. So when side is 10 centimeter, how fast it is increasing we need to find. So last step is here I'm writing d by dt of s at this is cube at x is equal to 10 is centimeter is equal to 36 upon you get as 3.6 centimeter square per second. This much speedily it is going to increase. So what is the speed here? 3.6 centimeter per second. So how fast means this much fastly it is going to increase the rate of change. So I hope you are understood. Once again, listen carefully. What was they given? They given for you rate of change with respect to time to the volume of cube is equal to 9 centimeter per second. And then side they given is 10 centimeter. So the volume of cube you know that as x cube. So now what we done here it is just differentiate with respect to t we done. So here given d v cube upon dt is equal to 9. Now d by dt of v cube is nothing but that is volume of a cube is x cube. Now d by dt of x cube is nothing but 3x square dx upon dt. So now here 3x square multiplying go to that side division. So 9 upon 3x square. 3 3s are 9. So dx upon dt is nothing but 3 upon x square. But what they say? How fast surface area of cube is when side is 10 centimeter. So they said for the surface area of a cube how much fastly it is increasing. For that purpose, s cube surface area of a cube is equal to 6x square. Now differentiate with respect to time. So here I am writing differentiate with respect to t. Then we get so ds cube upon dt is equal to 6. 6 is constant. D by dt of x square. When you find d by dt of x square as 2x into dx upon dt, so dx upon dt value already you know that 3 upon x square. Just substitute here. X and x square get cancelled. You get 12 3s are 36 upon x. But they said at x our side is equal to 10 centimeter. So now d by ds upon dt at x is equal to 10 centimeter is equal to 36 upon wherever x is there substitute 10. So substitute 10. 36 upon 10 means 3.6. It is centimeter square per second. Why centimeter square? Because it is area. So area because of that reason centimeter square, but it is per second I want to find that's the reason per second. Clear now? Anyone having any doubt? If you are not having any doubt, you just keep the thumb symbol so that I can understand you are understood. So anyhow here I can't find your comments. So let me check in my laptop. Then I can go for next example problem. Okay. Okay, let's check whether clarity is there or still clarity is gone. So if clarity is gone, then we'll go for next slide. So we are going to the next line. So in that line we are going to discuss third, fourth, fifth and sixth. It is going to be finished anyhow. Second we are solved. So third and fourth you do as a homework. And now we are going to discuss fifth and sixth. Okay. Third and fourth you do as a homework. We are going to solve now fifth and sixth in the next slide. Once we finish that one, then we will go for our. So we will close our session. Okay. We got this one. So kindly join in the next slide.